Do you know the difference between exponential growth and exponential decay? In an earlier concept you worked with exponential growth, so let's start with that. Exponential growth has the following function connected to it. Y equals A times B to the x power. In this function, A is the initial value, or that you could think of it as the starting value. B represents the growth factor, and x represents the time that we're working with. Whenever you have an exponential growth function, the growth is going to continue to go up and up and up and up. When we look at an exponential decay function, we can use the same basic form of the function, just like we did with exponential growth. So let's start there. Y is equal to A times B to the x power. Again, A is the initial value, or the starting value. B is the growth factor, and x is equal to the time. But when we have an exponential decay function, B is going to be different. B is going to be greater than 0, but less than 1. So that means that B will always be a fractional value. And that fractional value could be in the form of a decimal, it could be in the form of a percent, or it could be in the form of a fraction. So now let's take a look at a function that would represent exponential decay. Does this function represent exponential growth or exponential decay? Well, the first thing that we can notice is that there's a 0.5 here in the parentheses. That's our B factor, which is our growth factor. The 2 represents our time. Whether that's 2 months or 2 days or 2 years isn't clear by what we've been given. And the 2,000 is our initial value. That's our A value. So in this case, B is a fraction. It is 0.5, or it might have been 50% or 1/2. But because B is a fractional value, this function represents exponential decay. Does this function represent exponential decay or exponential growth? Here, let's first look at the growth factor. The growth factor is a 5. It's a whole number. Already we know that this is going to represent growth. Our time is 3, and our initial value, A, is 60. So we have A here, B here, and we have the x value, which often represents the time, right there. This is a function of exponential growth. Does this function represent exponential growth or decay? Okay, first, let's look at the growth factor. It's 1/2. That's our B value. It's fractional, so this is going to represent exponential decay. We can still look at the rest of the function. 50 is our A value. That was our initial value. 1/2 is our B value. And 3 is our time. Again, this function represents exponential decay.